Welcome to Daily Papers, the podcast where we break down the latest research into bite-sized pieces.
We all know that feeling. You're typing a question into an AI chatbot, you make a tiny typo, but you hit enter anyway, figuring it's smart, it'll get it.
But what if it doesn't? What if that tiny typo doesn't just confuse the AI, but completely derails its entire reasoning process? That's what a new paper called Lexical Perturbations Disrupt LLM Reasoning decided to find out.
The researchers wanted to test how robust or brittle these large language models are, so they took a bunch of standard reasoning questions and deliberately messed them up in a few very specific, realistic ways.
First, they added what they call keyboard noise. This is when your finger slips and hits the key right next to the one you wanted, so the word explains becomes explicanes.
Then they tried character swaps, which are classic typos. Melted becomes meltd, just by swapping two letters.
And for the third test, they did something different. They added filler words like or into the prompts. So which option best explains becomes which option best explains.
So you have two types of small typos and one change that just adds conversational clutter. The question is, which one breaks the AI? And the answer was incredibly clear.
The filler words, and had almost no effect at all. The models just breezed right past them. But the keyboard noise and character swaps, they caused a massive drop in accuracy, especially on more complex tasks.
Exactly. On some multi-step math problems, a few simple typos could drop a model's accuracy from over 80% down to under 20%. It didn't just get the answer wrong, it failed completely. This presented a puzzle. Why are typos so destructive when adding extra words isn't?
The researchers have a fantastic name for the phenomenon they discovered: attention diversion. To understand it, we first need to know how these models actually read.
Right, humans see words, but LLMs see something called tokens. A token is often a whole word, like the or cat, but for longer or less common words, the model might break them into pieces. The word unforgettable might become un, forget, and table.
This system works great for clean text. The word problem is probably a single common token that the AI has seen millions of times. But what happens when you make a typo and it sees porblum?
Suddenly, the AI has no idea what that is. It's not a common token. So it does what it's trained to do. It breaks the mystery word into the smallest possible pieces it recognizes. Porblum might become por, bull, and m.
And these fragments are weird. They're rare. The model almost never sees them. This is where the attention diversion kicks in. An LLM has a certain amount of attention or focus that it can distribute across a prompt. When it sees these bizarre, fragmented tokens from the typo, it panics and pours a huge amount of its attention into them.
It's a great analogy. It's like you're reading a book and one word is printed in a strange, upside-down, glittery font. You can't help but stop and stare at it, and you completely lose the thread of the sentence. The AI is doing the exact same thing with the fragments of a typo. It gets so distracted by the weirdness of poor bull M that it diverts its attention away from the words that actually matter for solving the problem.
And the paper shows this effect is most devastating on tasks where every single piece of information is critical, like those math word problems.
It makes perfect sense. If a math problem says Raymond was born 9 years before Samantha and a typo changes the 9 to a 4, the entire problem is unsolvable. There are no other context clues to help the model recover that lost piece of information. The attention gets diverted, the key data is corrupted, and the reasoning collapses.
Okay, so the problem is that typos create these distracting word fragments. The obvious solution seems simple. Can't we just tell the AI to spell check the prompt first, or just ignore the typos?
That's what the researchers tested next, and they found something even more fascinating. The problem isn't just the weird token fragment, and it isn't just the diverted attention. The two are fundamentally coupled or stuck together.
They ran this incredible experiment. First, they gave the model a prompt with typos. Then, they hacked into the model's brain, so to speak, and forced it to have the correct attention pattern while still showing it the corrupted, typo-filled words.
The result? The model's performance got even worse. It was actively harmful. It's like pointing a flashlight for someone, saying, the clue is right here, but the spot you're pointing at is just a meaningless smudge. It's more confusing than helpful.
This shows that you can't fix the attention without fixing the content. The two are linked. The damage is done the second the model reads the typo and breaks it into those weird fragments. After that point, it's almost impossible to recover.
And that's why all the common sense fixes, like asking the model to think step by step, or even using a more powerful AI to repair the prompt, failed to consistently solve the problem. The corruption happens at the most basic level of how the model perceives text.
So the big takeaway here is that for all their power, these massive AI models have a kind of Achilles heel, and it's our terrible typing. A single misplaced letter can create a glitter font word that the AI just can't look away from.
It's a great reminder that these systems don't understand language in the flexible, contextual way humans do. They are performing incredibly complex pattern matching, and a simple typo can introduce a pattern so strange that it throws the whole machine off course.
A fascinating look into the surprising fragility of modern AI. That's all for this episode.
Thanks for listening to Daily Papers.